Today, I want to run through examples of what a one-tail significance test looks like and a two-tail significance test. Last time, I just introduced significance testing with these new formulas using a two-tail test, and I got some questions based on how to know if it's a two-tail or a one-tail. Well, today we'll talk more about that difference. All right, so first up, just straight off the bat, I'll say this is a one-tail example. So our scenario, according to the United Banking Association, the mean amount of money people have in their savings account is $1,500. So mu, our mean, is 1,500. That is our population data. The Huntington Bank believes that people usually have less than that in their savings. They review banking records for 100 people and find that their average savings were $1,650 with a standard deviation of 100. Conduct a significance test to see if people have more in savings than the Banking Association claims. So here's how you tell if it's a one-tail or a two-tail. First of all, at the very end of this prompt, it says conduct a significance test to see if people have more in savings than the Banking Association claims. This should be capital B. All right, that's how you know right there that this is a one-tail test. So the difference between a one-tail and a two-tail. One-tail tests, the alternative hypothesis, HA, will either be a greater than or a less than. That's if it's a one-tail. If it's a two-tail, HA will be a does not equals. This prompt says conduct a significance test to see if people have more, keyword more, in savings. That means we're going to be using a greater than sign, okay? If this said less than, we would be using a less than sign. And if this said something along the lines of prove that or conduct a significance test to see if people have a different amount in their savings or something like that, then it would be a does not equals or anything but. All right, so that's how you tell if it's a one-tail or a two-tail. It's just based off of the wording in the prompt. Next, first step in the significance testing is hypotheses. So HO is always going to be the initial claim. Well, the initial claim, the population statement, was that 1,500 was the average people have. So our HO is going to be, if I can find mu here, so being covered up. That's V, whatever, should be mu, equals 1,500. Okay, that is the initial claim being made. That should be a mu symbol. For HA, all right, this, we're finding out if it's more than the Banking Association says. So this will be mu is greater than 1,500. So this right here, this is what's telling us that this is a one-tail test. Sampling proportion, you follow this formula. Remember, S over radical N. So our S, our standard deviation, is 100 divided by radical N. So N is the sample size, how many people they had in their survey. Well, this says that they reviewed the records of 100 people. So N is 100. So you would divide by the square root of 100. All right, so this is the same as 100 divided by 10. 10 is the square root of 100. Or in other words, the sampling distribution itself is 10. Next, you would do the standard score in order to find the p-value. In order to get the standard score, you have to take the observation, which is your x bar, minus the mean, which is mu, over the sampling distribution, this number that you just got. All right, so this would be 1,500, or excuse me, 1,650 was the observation, minus 1,500 over 10.